So hello everyone. We have already the first technical problem. My nice Stream Deck is not working, so my assistant, who easily wanted to press the buttons, it did not work as expected. But I hope this was the last problem for today. Okay, so let's start. I give you a short intro what's happening now. Today we have 3 presentations. The first one is Journey to GCP Infrastructure as Code and GitOps from Imants first and Miroszlav Magyarevity. I promised myself to not read the name, but already tapped in the first problem. They are from Leonteq and they show us their infrastructure. And the next talk is from Lorenzo De Micheli from Comerge. He is here on site and he will talk about their solution, how they use 9-managed GK for their infrastructure. And then as a third presentation, we have the journey to the cloud by Helge Rennicke. He is Director of Software Development from Market Logic Software from Berlin. So he is, of course, also remote. And then we should be around finishing at 6 o'clock. And you should watch the chat all the time because Silvana from Google is also here, remote, and she will do the pizza game. You may have seen my announcement, my short announcement yesterday evening, that we'll unfortunately not have pizzas here in the office as you cannot be here, but she will do some questions in the chat and you can answer them, and then hopefully you are selected and get a pizza delivered home. So we'll see if that happens, and if you could do a selfie with the pizza and send it to me with the permission to show it on social media, I would be very happy to use that as some advertisement. Okay, so next events are on the 25th of February. We'll have the Tech Talk Thursday. This is a sister event of us. It's a different meetup group. We'll there have Apfelkiste.ch, this is one of, I think, one of the 30 largest e-commerce shop in Switzerland. They will talk about their solution and their challenges and how they use Cloudflare in their setups. And then we will have a talk from Andreas Schneider from TX Group. He's the Chief Information Security Officer. We'll talk about DevSecOps, hot topic today. And at the last talk will be held from Stefan Bierer. He's the co-founder and chief software architect of Phoenix Real-Time Solutions, and he's talking about how the challenges with real-time at scale globally. Okay, the next Google Cloud Meetup is on the 16th of March. If you have something to talk about, please approach me. We'll hopefully have a talk from 9 again. And yeah. So my email address, very easy, tom@9.ch, or you can find me on any social media, almost any. WhatsApp, hopefully soon. No, not again. I don't know. Okay, and the pizza game. Don't forget it, Silvana. I hope you can hear me and you are in the chat, ready to start then later between the talks. So stay tuned. We'll give pizzas until almost the end. So we don't fire all the shots at the beginning. Okay, that was it from my side. I hope Valerie is finding the button for the break, and we'll switch over to Leonteq. Okay, so we have Imants first now in the camera, and I switch over to him now that he can start his presentation, and I hope he can start again because he started already. Let's go, Imants. The stage is yours.
All right. Good afternoon, everybody. My name is Imants First. I'm a software engineer in Leonteq. And today, together with my colleague Miroszlav, we'll talk about how we were migrating and implementing some of our new projects in Google Cloud. And we'll focus mostly on the infrastructure part and the GitOps. So let me tell you a little bit about Leonteq first. So we are a financial institution. We are a regulated organization, meaning that there are lots of rules that apply to us and how we need to do things. Leonteq consists of two main divisions, investment solutions and insurance and wealth planning solutions. So we are from the IWPS division. So we'll talk about more from the perspective of how we do things in wealth planning division. So we have some differences because of differences in the products and so on. And that makes some things which we can reuse and some things which are quite specific to our division. So the main thing which tells us apart from the other part is basically the workloads, how what we actually run in our applications and what we used to have on premise, and now we partially have moved to cloud. So the wealth planning solutions which we have operate in a business-to-business landscape, and we are basically offering a savings products with a very long time horizon. So we have contracts with the clients for which we have to manage their money in the insurance contracts up to 50 years. So all what we build with an idea that in some shape or form it will have to operate for a long time. And then from the workload perspective, this means that we mostly receive the data from our partners through integrations from using some nightly batches and a very low volume also from some UIs. But the main part where the workloads, where the biggest workloads happen, is actually this resource-intensive calculation which we do for our customers either daily or monthly. So this is a big calculation job which we have to do like once in some time interval in a day or so. And that means that for the rest of the time, the system is mostly idle. I mean, maybe somebody comes and looks at some report or some data, but that's very low load compared to what happens in these allocations. And this causes us several challenges. So one of them is productively, how do we do it cost efficiently, that we can scale up for this calculation and scale down when we actually don't use the systems, and also in our testing approach. So we do a lot of testing up front whenever we release any change to production. It depending on the components, the ones which are involved in the calculation are going through some pretty big test suites, and there as well. So we need to find a way to scale them up when we want to run the tests and save the money basically when we don't need the computing power. So I mentioned we have two main systems or products. So there is one which has been operating on premise for 10 years, and we to the will of the solution in the future. Yes. Okay, I'll make a short break. Let me know when I can continue. All right, let me go. Okay. Okay.
Okay guys, sorry, I think my notebook almost exploded. I hope it can recover without I have to stop. So the problem was that this. So I think the problem was that I took too much resources from my notebook, but I'm a bit hesitating to restart all the things and hope it recovers. Oh, now YouTube tells me the connection is good. Good, at least you see me in a good shape. So I hope you have patience that I can restart the sessions, the ninja sessions, to the guys, to Imants, without it. So give me just a second. I think maybe Silvana can already start with pizza, the first pizza questions in the chat. So I can easily switch here. I suggest that we start over. I'm not sure how much there is, so okay. Can someone confirm that you can see me clearly now on YouTube? Okay, I see them chatting in the chat, so it's good. Okay, I start the ninjas again. Okay, so I guess we can continue or try to continue. Imants, can you hear me and can you start over? And I hope it's working this time.
Yes, I can hear you. I'll then start from the beginning again.
Okay, sorry guys. Maybe I need to buy the new Mac. 2020 is not new enough. Okay, the stage is yours again. Imants, let's try again.
All right. Hello again, everybody. Let's try to do it again. So my name is Imants First. I'm from Leonteq, and I'll walk you through our journey to GCP. I'll talk about how we built some new software for GCP and how we migrated some of the existing infrastructure to GCP. let me introduce Leonteq a little bit. So we are a financial company. We are focusing on two main business lines. One is investment solutions, which is mostly related to issuing structured products. And the second is insurance and wealth planning solutions, which look into the long-term savings products and providing some capital protection for them. So I will talk mostly from the perspective of the insurance and wealth planning solutions division. There are some similarities, but also very big differences between the divisions and how we operate. So this mostly applies to the insurance and wealth planning part. So our systems, or basically also the products which we offer, have some certain characteristics which causes some challenges for us, which might be different from other places. So what we do is we do a business-to-business operations, and we basically do financial calculations and advice for our partners, meaning that we receive some insurance-related data from them. We process and return them back some investment advice. And how this works is that we are managing financial products for insurance policies, which has long time horizon, around 50 years, which means that whatever we build, we have to maintain or in some shape or form keep the system around for 50 years. We have the contracts with the end clients to maintain their policies for this time period. What it also means is a business-to-business solution that the data which we process is mostly coming as batches from our partners. But with some of the partners, we also allow them to interact with the system through UI. So they make changes to policies through UI, but those are still relatively low volume of changes. So it's not a public application, right? And then what we have is this daily or monthly calculation process, which operates on the policy data and basically calculates the investments or the allocation, how to invest that money, which is coming from the partners. And this is a CPU intensive calculation. We basically have to go through all our policies in the system and compute the new positions and suggest the trades which we need to do. Because of that, we also do a lot of testing. We have to be sure that whatever we calculate is right. So depending on which components, but the critical ones, we run some extensive test suites, which on premise can take from 1 hour to 8 hours. So on commit, we run the shorter one for 1 hour, and then the nightly one is the longer one. And we have two main systems or products. Or for insurance, which we have been developing on site for long time already, and we have to maintain it and improve. And we are building also a new one, which is more oriented to our banking partners, but the workloads are still similar. It's very peaky, and we need to process lots of data in short interval, and then it's mostly idle. So how we approach the whole development process. are basically three main values which we look at. We take security very seriously, and with help of Google's infrastructure, a lot of those things are kind of given out of the box, are much more easy to handle than on-premise, where we have to do everything. And because of the long time period, we really care about the sustainability and how we actually can manage this solution for long term and with minimal effort, and actually focus on business development, not maintainability. And also because of that, we tend to try to keep things as simple as possible. Yeah, not always possible, but that's a goal of us. So from development concepts perspective, we focus on working together with the security teams and operations teams to really streamline the process. We keep all our infrastructure as a code in Git and manage it using the GitOps process. We think about the infrastructure as immutable, so we never go and click in the Google UIs, or at least we do it in our research and development phase, maybe when we try things out. But as soon as we want something to deploy even to dev environments, we work with infrastructure as a code. So we work with microservices and continuous delivery per service. So on premise, that was not the case. We had a bit more like a distributed monolith there. Also microservices, but they were not separated well enough. With the new projects, we build it in a much better design from scratch, and hope we can keep it that way. So we look into using managed services as much as possible. Yeah, and also the audit trail is important for us as a regulated company. So what working with the cloud gives us most is the ability to scale down to zero, because for the workloads which we run like maybe an hour a day and then 23 hours, basically the system would be idling on premise. So we look into solutions in Google where we can actually save money when we are not using the resources. And mostly for testing, we look into running more parallel tests and so on, that we can scale it up, run them, and then scale down again. And with the managed services, what we get also is that we have way fewer people in our team managing the infrastructure and things around it. So we currently, in the development mode, we have 3 developers working on the infrastructure tasks, and maybe not even full time. So from security, what we get, we get all the encryption out of box. We make sure that all the communications are secure between all of our services. We leverage Google's identity-aware proxy for integration to our Active Directory, and we make sure that all the authentication is token-based, and authorization as well. Yeah, we utilize the artifact registry's vulnerability scanning of Docker images. So in order to promote some images between environments, they have to pass the checks. And we are looking also with Kubernetes. So basically what we do is, for the new code, for the new services, we use Google's Cloud Run. But for the projects which we are slowly moving over to Google Cloud, it's easier for us to shift them into the Kubernetes cluster. So we have built a Kubernetes cluster, the managed one we manage it with Terraform, and it has HTO and MTLS enabled, and so yeah, this is kind of the big part of the work which we have done. So from environment perspective, so each environment is expressed as some code in Git. So we have like development, UAT, pre-production, and production environments. How by design we have built them, they are basically dynamic in a sense that you can spawn an environment by provisioning the resources, and you can also destroy it. So we have a Git repository which describes how the environment should look like, and then when some changes are pushed, it actually triggers Terraform-based deployment which provisions those resources. What we have done differently from the on-premise, so our development process has changed in a way that we now develop more on the dynamic environments, basically that users can provision environment for them, use them for a while, and then discard it when it's not necessary anymore. And then there are the certain path for any code change to get to production with different approvers in the process. And those are then static environments. They are never destroyed. So an example of the Git repo describing an environment would be like a small repo like this. The important part is the config YAML file. I'll show in a minute how it looks like, which describes how the environment should look like. And then there are the cloud build scripts, basically for deploying, destroying environment, and for promoting images between them. And in the case of Terraform code, we tag. I'll get back to that in a moment. So the config YAML in the simplest case looks like this. It says in which Google project the environment should be provisioned, and then you have some services which could be enabled or disabled in an environment, and you have the versions of those services. And in addition, you can have, depending on if the environment is integrated with partner or basically any external environment-specific parameters would go there as well. So when we look at as an environment as a whole, what it is, right? So this is this config YAML, which is describing what the environment should look like. And then there is a bunch of code which is coming with it, which actually gets deployed in the end and makes up the real environment. And so what do we have there is then the cloud build YAML files, which tell us how the environment will be deployed on a high level, basically what steps are there. Then we use a custom built Docker image with some tools which actually do the deployment. And then we have some application images which will get deployed to the environment, and we get some infrastructure code which is expressed as a Git repositories with Terraform modules. So all of these pieces together is the code which we first of all have to secure and then deploy. So all of these components go through our software change process, and everything has to go through a code review and tested and approved before it can get deployed anywhere. On the Google side, what we do is we played a bit around with different ways to structure our projects there, and so this is the structure which we ended up with, that for every business line we have a folder for environment, and then in the folder we have a bunch of projects which each of them is a separate which is managed by a separate Terraform state. So for every application which is set of services, we'll have a Terraform state and the project with the resources which are provisioned for it. And there are some shared things which we share between the applications. We have our continuous delivery related things which are responsible for the promotion process and keeping everything together. And there could be a Kubernetes cluster which is shared between the applications in the environment. How we look at Google resources in general, so basically we say everything is code, right? And everything what we provision in Google is just some sort of resource. And there are simpler ones which you get basically from out of the box Google services like storage buckets, schedulers, and the queues would be the examples which we use. And then it's our software which gets deployed on Google's infrastructure, which has also then our code in addition. But in principle, how we provision the resources is the same. We do it with Terraform, and we specify some parameters how to instantiate this as part of environment. From development process, so we have a slightly shorter process for libraries. It means whenever we have some library, we are mostly a Scala company, so we work with Scala. And for libraries, what we do, it's a simple process of creating a pull request, then some unit tests are run, there is a code review always, and only then when the pull request is merged, we create a tag and publish the artifact to artifact registry. And we treat the infrastructure libraries, which are Terraform code, exactly the same way as we treat our Scala libraries from the process perspective. They go through the same process. And then the second kind is the deployable ones. So this would be the Docker images, which now would be built and then contain inside some of the libraries which were built in the previous step. And these now go through dual promotion process to production. So basically, advanced tests on those libraries would be part of just testing the business functionality here. And how we organize it with the GitOps is through the pull requests to the environment repos. So whenever we want some code to be deployed to an environment, in let's say in this case our user acceptance testing environment, so whenever there is a new artifact built and which has passed all the checks it had to pass, we will try to get it on an environment. So we will create a pull request for environment repository updating, let's say, a service version or the infrastructure code tag, which we want to get on that environment. And for that, we will also generate a bunch of checks in the GitHub, which have to pass before the pull request can be merged. And when the pull request is merged, then the update is merged to the master branch of this environment repository, and it means that then the deployment will be triggered to that environment. And when that happens, we initiate the next step for the next environment, which process-wise is the same. It's just that there will be a different checks which need to pass. So for some code to get to UAT, it's automated, so it has to pass all our test suites, and then it's deployed there, and then there the manual acceptance testing is done, and when the business and QA sign off, then we put it to the staging environment, and then the release management has the final say when we can proceed with it. So how do we promote the changes? So yeah, it's basically the pull request part of it. I explained. We raise a pull request, but also to actually make sure that only the code which is approved for a certain environment can be deployed there. We need additional checks in place. So what we found out, the easiest for us was to create a new artifact registry repository for every environment where we want some code to be deployed, and then we set it up in a way that the deployment job for an environment can only deploy code which is in the repository which it owns. And then the promotion process, when we actually have signed off some code for the environment, we copy the image over to this repository. So we never rebuild. We build the image once, and then we just copy it to the places where we want to deploy it. How this whole thing works together. So we think of it as a three-piece software. So on premise, we used Jenkins for doing most of this, but we didn't see it as a good fit for the cloud. So what we found out that there were pieces not fitting together, or either it was hard to manage in a cloud native way, and so on. So in the end, we ended up with a solution which consists of three pieces, where we have Git as a source of truth of everything. So it's the only state which we have. So there is application code, infrastructure code, all the configuration, all the audit is there. Who changed what? Then we utilize the cloud build as an execution engine which runs all the tasks, the builds, the deployments, and so on. It's set up in different projects and with the access rights that on a finer granular level that only the job has access to building images and nothing else, or then the dev deployment can deploy to dev. And then we have a small application of our own which actually tries to tie it all together, which defines our process and basically fills the gap between the Git and the cloud build. So what it gives, in addition to us, that also the whole pipeline goes through our software and release process. So the code changes to the pipeline, and everything has to go through the same process as everything else. Yeah, so why we ended up there, that we looked at different combinations at the Jenkins, at Jenkins X, at Spinnaker, and somehow when we evaluated it, we couldn't find a good fit. So either it seemed too costly to maintain, or it didn't do exactly things as we wanted. So we ended up with our solution for orchestrating the process. And I think now I can give the floor to Miroszlav to continue.
Hello, hello. I hope I'm back. Good, I hear me on YouTube again. So I hope that helped now to push down my CPU. And I prepare now to have the slides of Mirosz. So give me a second to start the new ninjas. I suggest that there are some more pizzas in the chat, so I can easily switch here to the next one. Okay, Mirosz, I try to open my ninjas. Okay, so Mirosz is shut down. Mirosz is on the wrong spot now. It's not Imants on the picture, but I'm handing over to him now. I hope I have that correctly, and then we can start.
Yes, so hello, my name is Miro, not Mirosz, but close enough. So let's talk a bit, thank you, Imants. So let's talk a bit about Terraform. So Terraform we use to manage our cloud resources, and it acts like a reconciliation, like a controller, something like in Kubernetes with deployments. So it basically tries to reconcile the state, the desired state and the actual state. So it knows what you want it to do, and it knows the current state, and basically tries to make it as you wish. Then what next do we have? Yes, we use Terraform best practices. So for the code, we use this plugin which does the formatting, does documentation for us, automatic documentation, validation, and length. So we know when we commit the code that the code is actually clean. DNS, we express DNS as a Terraform configuration. We use DNS for the top domain and all the subzones. The subzones we link with the main domain. And the fourth point is we couldn't buy a domain in Switzerland with Google domains. Unfortunately, we hope to see it soon. So we just pointed the domain to Google, basically. DNSSEC enables us to cryptographically sign the record, so that the end user actually knows that the record hasn't been changed. So if you look here, you see one of our zones, and the verification, so analyzer of the dot zone, that then ch olap.ch, which is our domain, and dev olap.ch. We use Google Cloud Build, as Imants has said, to build artifacts, to do tagging on the source, to do deployments. We have two types of artifacts, libraries, and proto-gRPC API definitions that we so basically we create jars and push them to Maven artifact registry. And we also do services as Docker images, also pushing to Docker artifact registry. Yes, Cloud Build custom images. Yeah, okay. So we have custom images with all of our tools that we use for tagging, building, and deploying. Yeah. Then we use Google Cloud Run. So why do we use Google Cloud Run? It's managed, so not much really that we need to maintain it. So the reasons are cost, scaling to 0, security, authentication. It's a managed service. It's available in Zürich, I think since a few months ago. But we really can't use it since domain mapping doesn't work in Zürich. So we can start the services in Cloud Run, but we cannot map the domains, which is unfortunate. And then setup is much more simple than in Kubernetes. We set up Cloud Run with Terraform. We have our own Cloud Run module. So something about Google Kubernetes engine. So basically, we use it to lift and shift the legacy services to Kubernetes. So we have a complete isolated private cluster with Istio that we manage ourselves. Google is actually a few versions behind for their own reasons. We use workload identity, meaning that we connect the Kubernetes service accounts with Google service accounts, and then use IAM permissions. Then we do node pools for different workloads and mutual TLS for all services by default. So we create tunnels. So basically, GK is running in a private VPC, and to be able to use it from the cloud build, we create a cloud tunnel through IaP, so we can access the proxy and talk to Kubernetes API server. This way we can work across networks and access Kubernetes. We use Cert Manager for Let's Encrypt wildcard certificates. This is all running in Istio. Basically, we just get the wildcard certificate once for environment, and that's it. Domain verification we do via DNS. So we don't have any services that we expose by default to outside to use for domain verification. We just publish a text record in the zone, and that's how Let's Encrypt knows that we are legit. We use identity-aware proxy with external identities. So yeah, we use a load balancer also with predefined static IP address. So one load balancer, I believe. Okay, yeah, we use one Terraform apply to both create a cluster and configure it. If you read about the best practice, the way usually people do it, they create a cluster, then the second Terraform apply is to configure it, and the third one is to apply services. So we were able to combine these two into one, and hopefully the third also in some future. We use Helm tree provider for Terraform and Kubernetes provider for Terraform using proxy URL to access a private cluster. So basically, in kubeconfig, we just add a proxy URL to tell Kubernetes and Terraform to access the cluster. In Kubernetes provider, it works by default. In Helm, we had to configure it a bit, rebuild, and it works. Kubernetes provider for Terraform doesn't support all custom resource definitions like the ones that Istio has. So we decided to use Helm 3 Terraform provider with Helm charts. And the alpha version of the Kubernetes provider looks very promising because it's supposed to work with any resources. So hopefully in some time we can use it. Here you can see one cluster. This is mine, actually my environment, running in Zürich, so Europe West 6, and with some other details. So yes, as I said, we use the Google Identity Aware Proxy. We use it for central authentication, authorization with our LDAP. It provides the details about the current user, about its groups, and then the applications are free to determine what the actual user can do in their own scope based on this groups and user info. And of course, we use external tenants. And this is how it looks like the icon to sign in to our application. So you basically sign in only once for our oral applications. We use PubSub basically to asynchronously communicate between services. We use Google Cloud endpoints as a synchronous communication between services using gRPC endpoints. And also we expose the services as REST using JSON transcoding by endpoints. Yeah, maybe we'll do the same with Istio. It remains to be seen how we will actually do it. Artifact registry, we used to use GCR. Now we use artifact registry for Docker and Maven artifacts. Docker images are promoted between environments, as Imants has said. This is a quote from a blog post, I believe, some time ago, where you can read how we actually use it. So quote by Imants, where he says that migration from on-prem registry to artifact registry has been a very smooth experience. Artifact registry builds upon container registry by providing us a single place to store, manage, secure, and share both Maven and Docker artifacts. And given artifact registry is fully serverless, unlike our on-prem registry, we never run out of space and pay for what we actually use. Artifact registry currently doesn't support Helm3 for the charts, but I believe it will, by knowing Google, it will happen in the future, probably support for other artifacts. So I'm optimistic. So artifact registry, here we have an example, like one Docker, one Maven registry that we use in the Zürich region. We use secrets manager, so we have auto-generated secrets and external secrets. Yeah, because it's a managed solution, we considered using Vault, but this seems to serve our purpose. We use Firebase for hosting auth application for identity aware proxy, Firestore to store data, which is managed in pay-per-use, Cloud Functions on response to data, to changes to data, authentication. Data storage, we use 3 types of data storage buckets because they are cheapest, key value storage. SQL for legacy reasons, so we would like not to use it in paper query, use paper query model. And document storage, we use Firestore key value, where we can have indices on other fields in JSON documents and credits on other fields, not just the key field. For logs, we use Stackdriver. It works with the VMs, with Kubernetes, with applications, Google services, so we have one place to store our logs. And our applications output in JSON format where the fields are indexed and available. So some lessons learned. So deploying even a managed GKE with Istio and authentication using Terraform is a huge effort. It took us some time to actually get Kubernetes up and running with Identity Aware Proxy. Google Cloud Run is actually much simpler. It's basically Kubernetes and serverless, right? Cloud Run. We use a managed solution, so it's much simpler and can cover most of the use cases we have for microservices with REST, gRPC, HTTP interface. And Terraform is still a work in progress. In 90% of cases, it works great. But then it requires workarounds with external providers, null resources, shell scripts, etc., to fill in all of the gaps. And yeah, now we open for QA if there are any. Thank you very much.
Okay, thank you, Mirosz and Imants. Hope to fix here these the right cameras, and you can shout in the chat if you have any questions. So it gives a bit of a delay because YouTube is a bit behind. Okay, so I fixed it here. So are there any questions? Checking the chat. So if no questions, then I would suggest to move on. Okay, so thank you very much to Mirosz and Imants.
Thank you very much.
I wish my computer, my nice MacBook, good recovery. Okay, so thanks you and see you.
Thank you.
Thank you very much.
Okay, so welcome Lorenzo. I hope we have a better performance now. And Lorenzo is talking about 9-managed GK, how they migrated from VMs to 9-managed GK. So the stage is yours.
Okay, hello everyone. Yeah, my name is Lorenzo. I work with Kubernetes since 3 years, but I started to program with mainframes. So.
Okay, thank you. Bye.
Okay, I work since 2 years in Comerge, and so we did a journey from virtual machine to Google Kubernetes engine, and yeah, today we will explore the journey. So why and how we moved away from these virtual machines. So of course, first we had a problem, and we have an application, a chat application that is built on Spring Boot and is deployed on more than 40 customers on a Tomcat, Apache Tomcat application server. So in each customer, a different number of users, from 10 to 5,000, so the size is quite different among customers. And they are located geographically in different places, so Switzerland, United States, and Asia. And the number of users go down, but mostly grows in time. So we have to enable customers, new customer, install new customers, and also sometimes we have to decommission one. Everything was installed in virtual machines, so dedicated virtual machine for big customers, and as well shared virtual machines, so big machines with many customers deployed in one single application server, which of course leads a single point of failure. And among our customers we have also hospitals, so I will explain a bit in deep the problem what was. So on the left side we have customer, so they share a virtual machine, they have an application server and different application deployed to it, so from different sizes. The problem comes when just an application grows and the virtual machine is too little, so either we move the application to another virtual machine.
Can you take the mic?
Oh yes, I will. Et voila. Good? Yes. Where I was, yes, the application is growing, the number of users is growing, or just for whatever reason they need more capacity, and then we have to restart either the virtual machine or we have to move it out. So in any case, it will result downtime from the application 2 in this case, or for the old customer residing on the virtual machine. And also we can end up with this, so wasting resources with a big virtual machine and a tiny application of the. So anyway, we can restart the application, the virtual machine, but anyway, it will result in downtime. Okay, so to solve this problem, we have some requirements. We want to use better the resources we have. We don't want to waste. We need to be more flexible, improve the scalability. So when more users are coming in, so we need to serve them properly, and we want to avoid downtime and maintenance windows. We want to be a bit more independent from our providers, so where the virtual machine are not hosted but maintained. And we want to increase a bit the visibility, because at the moment the virtual machine has, if you want to look at the logs, you have to SSH on it on each of the 14 machines or 10 machines that they were. And also we would like to have a continuous integration relying on the infrastructure as code. So voila, the orchestrator is like Kubernetes is matching our requirements, so it should solve the problems. So for the resource optimization, first we will have the node auto-scaling. So when new instances comes into play, they are scheduled. Then Kubernetes just watch if there isn't enough space and just create a new nodes. Yes, it is a virtual machine, but it's also a node. And also we have the pod auto-scaling or the pod scaling, so we can increase the number of the instances upon a code change. So as well, we improve the scalability. Like I say, the horizontal auto-scaling is one, and now our application is fully scalable. So I will speak about later how we did make just an application scalable. So, and the deployment and the maintenance downtime, this was not really a big issue, but yes, it's always good to have an application which doesn't have downtime while deploying it and rolling it out, and when the virtual machine, the nodes are just upgraded. Then Kubernetes offers rolling deployment, which basically when our new release comes, it starts to spin up in a new pod, in a new instance. And then until this is ready, the old version still serves the request. And when the new version is ready to serve request, all the traffic is routed to the new instances, and the other one are just killed, terminated one by one. And this is good, and there is no downtime. We would like to be more independent, just ask less support requests for particular topic by changing the application server configuration, the memory settings, and so on. And also we want to, so by increasing the visibility, so Kubernetes offer the possibility to install Grafana, Loki, and Prometheus as a stream ingesters. So we have all the resources, metrics, and all the logs aggregated on it. So it's very easy to access them from a web browser and correlate them as well. It's quite tricky, but you can. And yeah, have a continuous deployment which is reliable. And we have now Argo CD. At the beginning we didn't, but Argo CD works very well for our experience. So now I will go through some points. First, regarding the node auto-scaling, how it works. I just introduced that before. So just, it's an easy GIF here, but you can see that when the workloads put on Kubernetes increases, it just check, oh, there are enough nodes, then it just spin up a new node and places the new pods there, and they shuffle them among the old cluster and node pools. And this is how it works there. So for the node upgrade, I took this GIF from internet, which it quite depict how a termination of a node works. So first we have the cluster, we have a set of nodes, and the nodes are distributed among zones normally. And when it comes to an upgrade, so how to avoid downtime. So in this case, just the node 1 is killed, it's terminated, it's drained, so all the workload of the pods, it's just shuffled, scheduled to another node, in this case node 2 and 3, and the node is shut down. And then a new node comes up with a new version of Kubernetes, and then all the workload will be scheduled there again. So this is also will avoid downtime during these upgrades. So at the moment we can have upgrades of the node without any downtime, which is very good. So then we are convinced, let's do it. Yeah, as Dilbert says, yeah, it's not that an easy journey. And yes, it doesn't solve all the problems, of course, it just also creates some others, but the quality of the software just increased just by doing this step. And okay, I will come later with the problems. Yeah, but what's the plan now? So what shall we do what shall we do from virtual machines going to an orchestrator? So first we need to create a POC, proof of concept, then choose carefully the provider, the pros and cons and the performance. We'll come later about that. And also make it production ready. That's the real challenge here, because making a POC is quite, I won't say that easy, but yeah, it can have, so make it production ready, it's the real challenge here. And then afterwards, just slowly going to development environments, see how the application behaves, all the scaling and so on. And just rolling out until we had the first productive customers rolled out. So I worked previously with OpenShift Online for 1 year, and then for me I was just used to that, and so the POC was going to be there at first sight. And so we basically are the steps. So you put your Spring Boot application in the container, which was quite easy for us, was not that complicated. And we created a minimal resource kind specification without using Helm, just for the POC, just the deployment configuration of the application, an ephemeral database deployment just to hold the data, and as well the services to know how many pods are available, and also the route, so the reverse proxy configuration. You apply the resources and run it. Yeah, okay, it's not that easy as it sounds, but in 1 day we could accomplish that, and it was working. But the production road, it's a bit more difficult. So then second, after the POC was convincing us, so we just have to decide what to do. I was really an OpenShift fan because it's easy to understand, and it's less complicated. But then we have to decide among both. We tested both, and we just also carefully evaluated each point here. And at the end of the day, I was more for Kubernetes, vanilla Kubernetes, because of the numbers. And yes, then afterwards, the managed offer of Google Kubernetes Engines won over, and the key points were so the cluster auto scaling. It's something that OpenShift let's say dedicated, so couldn't offer. We have to open service requests to have new nodes and scale up at the time, so scale out at the time. So for us was not really nice. And also we accepted the CD and CI integration because at the time there was only a plan to introduce Argo CD, and we just say, okay, let's do it with script. Horrible, but we did it. And after they delivered, it was very nice it's very nice still to use Argo CD as a deployment help. Also, the learning curve, it's steep here, so in comparison to OpenShift, but Kubernetes is the foundation, so it's really worth to dig on that and to learn that, because yeah, OpenShift is anyway based on Kubernetes. So also OpenShift was at the time expensive, I think, because of the upgrades. And then we did some performance benchmarking, and yeah, somehow I don't know why OpenShift was slower. It depends on the machines or on the background, not from the technology probably. And yes, the POC is nice, but let's do it in production. So the way into production was quite long, and it took some time, some more iteration. And here I depict more or less the steps we took. So the first thing we did, then we had this this rudimental container deployable on OpenShift. So we have to change some parameters, and then was deployable also to Kubernetes. Was not an issue. And then yeah, we have to create Helm charts. So Helm charts, it's per se a challenge. Yeah, you have to put a grader on the screen just to indent correctly the YAML. But in other hands, I had a very good documentation, so we could also learn a lot from this documentation. Just two hints I can give. It's like the parameterize everything you can on the YAML, on the Helm charts, on the templates, because you don't want to create a Helm release every time you need to change something. Just the more you parameterize, the more you're safe on new chart releases, and use fixed version dependency. So don't use the tilde. So try to avoid it, because we had an accident on development, and we just pushed a chart with missing dependency. No one complained, but the whole distributed cache went down. So just my suggestion, our suggestion is not to use that to get some special surprise afterwards. And also we use 3 separate repositories, one for the Helm charts, where the charts are released, for the templates are released, just for using, just to be used from different customers as a reference, and also the infrastructure repository, where the values of each customer are defined there, and also a third repository where you put your application manifest of Argo CD. That Argo CD is able to know which application names in which namespace have to put and to manage. So second, after we have the Helm chart, we are able to deploy it. So I just present the CI pipeline we have right now, a big picture, not the one with the script, because it was horrible. Yes, first you build we just build the image and tag it with commit hash, that it goes to the container registry, Google Container Registry, and then afterwards this commit hash is just checked in the infrastructural repository, and then Argo CD just go and grab the new revision of the infrastructural code and then it says, okay, there is something which is not synchronized with the namespace, then I will apply the unsynchronized resources. And at the moment it starts, for example, a rolling deployment. So the new version of the software is rolled out and the old one is terminated when the new one is is ready and available. So here as well, we have another repository. It's called the Application Manifest repository. So is where also Argo look for new customers, new applications which are defined or which are deleted. So, and this application custom resource definition just point to the infrastructure of the application, so to the other repository. So Argo CD can spin up and create the new application, the new resources, and synchronize the namespace. Okay, so then now we have a Helm chart. The Helm chart can be deployed upon new development, and yeah, Argo CD is happy with that. So, and then now we have to make the application really scalable. So the next step was to remove the state of the application. Of course, the application had so the request of the application the requests were round robin. Yes, I don't know what to say. They used the round robin strategy to route the request on different instances. So one request is not really need a user session, but we have WebSockets, and each instance we have different WebSockets which are connected with the client. And also we have usually also scheduled task. It's just an operation that needs to be executed once per customer. So like let's say just lock the user which are expired. So you have to do it once. You don't want your 3 instances at the same time just to update the database. Will be a mess. So and then also we have memory caches. So how we solve that? Yeah, moving the caches is quite easy because yeah, Hazelcast, which is the technology we chose, because yeah, has a Spring Boot integration, it's well maintained chart, and then it's doing more than a cache. So moving the cache was quite easy. So usually there are maps on the application, and then you just change the implementation and that's done. The scheduled operation, we use the distributed lock. It's also a feature offered by Hazelcast. And yeah, when an instance the other instances cannot do the same operation because this operation is already locked. So this workload ideally should be delegated to a job, to a Kubernetes job, which is a cron job basically that does the work. But this kind of operation we have scheduled operation as not really CPU and memory greedy, so we decided to left it there for the moment. For the WebSocket, the story was a bit more difficult, but we used the distributed topic service of Hazelcast. So it means that a user just write a chat, push enter, goes to one instance from the reverse proxy, just choose one instance. It goes there, it write in the database, and then it just publish a topic. And all the people involved on this chat will be broadcasted because all the instances read from the topic and then knows exactly which device has to be notified with this new message. And then was quite hard work to make it this, but was really funny. And also, and also the log files and the media. So our application just stores files, media files, and at the beginning we just used the network file system, and yeah, because it was transparent. So you write a file in your mounted folder on your container, and it just magically is available to all other instances. But yeah, turned out that was not really reliable, and we had kernel panics on one node one day, and another day on a node upgrade we get stuck with some, so the application was not able to write anymore on the file system. So we said no, we moved to Google Cloud Storage. A part of it's very stable, a part of the 13th of December. Yeah, we get quite a short surprise, but I must say that works well. Yeah, and also another point are the log files. So when the log files has to go away, because depending on the rotation policy that we put, they can take megabytes, 100, 200s, and one day the pod will explode and then will be restarted. So thanks to Grafana and Loki, now you just tap on the standard out of the container and we get everything ingested by Loki, and it's very nice. We have everything aggregated, we can read everything, we can search also through different customers. Okay, so now we have the application scalable. We removed all the states, all the file system that we write on the pod, on the container, sorry. And now we need to stress and to see what is capable this application on a tiny container. Of course, we just run into some performance issues because the application was written and was working on a virtual machine which is big, and actually we, from the 6 GB of RAM that it used to run with, now we use 1.6 GB, and it's working well, except for the thread. So when the number of users is huge, then it just increased the number of threads until the memory of the machine just crashed. So this was quite a nice lesson learned, how to handle out of memory killed from Kubernetes. But we solved that, yeah, eventually to make some other code which handled the number of threads and the capacity of the pod. Yes. After that, one of the most important part to go into the production is the monitoring. So a must is always to implement the container checks and like liveness and readiness, because we need to tell Kubernetes what to do with these instances. If we don't tell that an instance it's not healthy, it cannot process request, he doesn't know. But if we tell him, he can ask us, are you fine? Then Kubernetes will either stop the request for a short moment until we are healthy again, or just kill me because I'm not able to survive anymore. Then, of course, we can monitor with Prometheus all the metrics of the resources. So also Stackdriver offers us many metrics for the DB connection, the DB resources, how it's using them. Also we can see all the requests coming through the reverse proxy and so on, but this is just to monitor and see. So what's important for us is that the alerts. So we have alerts that are tuned on the inside the cluster, the health checks. When something is go wrong, we get notified. Most important is the pod restart, so we get notified when something restarts and the pod just doesn't answer anymore. And also outside with New Relic, we get some availability checks that inform us if an application is not reachable from outside, and also we check the readiness of the nodes. So because sometimes the node just got restarted, they just killed, but Kubernetes is done for that. But we want anyway to be notified when some virtual machine of the nodes it's crashing, and also we ingest the logs as well. And everything is select, so we have under control everything every time. So now we have also the monitoring, and just now let's nuke a bit the application. So I call it's chaos engineering. We do it in a soft way, not like other big companies, but the target here is to understand and know what your application is capable of in case of failure. So we have some scenarios that we do every time, sometimes. So we reach the state that if we delete a complete customer namespace and just recreate it, everything is there as before. So actually it's funny because once happened to me just to nuke a test instance, and then I recreated that, and someone was using that for a presentation. Just after 2 minutes that I restarted, I reinstalled the application, and no one noticed something, so that was a good achievement. And also we just kill Hasekast instance, distributed cache instances. We delete application instances to see how the communication between the parts works. So we need to know that if someone is going down, is coming up, is reconnecting and speaking and handshaking correctly, because we want to be able that the resiliency of our system is good. Yeah. And also, last but not least, also the node upgrades. So we need to be sure that when during the night there is a node upgrade, everything should work smoothly and we will have no downtime. For doing that, yeah, we need the pod disruption budget, just to tell Kubernetes how many pods must be ready, not starting but ready to serve request before to drain a node. So that guarantee a certain of service that avoid downtime, and also have redundancy, of course. So you need to have always more than one pod up and running. Yeah, another aspect to keep care about it after your application is stable and so on. So you need to size your node pools, your cluster, and so on. So that was quite a funny, nice decision to take at the end of the day, because yeah, the bigger the node it is, you can host so many pods, and Kubernetes is also happier that it can shuffle pods between nodes in a better way, so it can play Tetris better. But if you have smaller nodes, so if a node just explode or just got restarted, so the blast radius it's smaller. So if I have 5 pods running in a node and this node disappears, there are just 5 instances that are gone. If I have a huge node of 32 gigabytes, I have hundreds of pods running inside, then hundreds are gone. So when hundreds cannot serve anymore any request. And also another aspect to tune is the resource request. The resource requests of the pods are the minimal resources needed for this container to work. And this is very important to know the limit, because this is it just influences directly the cost of your infrastructure. So you need to test and see. So because Kubernetes just if you say you have 1 gigabyte of resource request, or no, 3 gigabyte, let's say, and you have a node that has 10, you can host at least you can host 3 pods. no more. So you have to be careful about that and put the right measure that your, for example, your application can bootstrap without problems. But the nice thing of the cloud is that you can try. So you just order some nodes, you make it auto-scalable, you schedule your pods there, and then you're fine. And you can just play with it. And the next day you can delete the node pool, and you know exactly what your application has a request needs. Okay, so now the journey is also finished. So the learning curve, there are many memes on internet about that, and it's really funny. It's steep, yes, for me as well, going from OpenShift to Kubernetes as a Java developer was like, ooh, it's a lot. You see behind the curtains. But after sometimes you get really used, and that it's not that difficult as it might see at the beginning. And how we did overcome that, we organized some workshops, technical talks. We have some people inside the company that are enthusiasts like me, and we follow all the transitions. But the best way is to use it. So you cannot go deep so much if you don't use it. So that's my recommendation. So yeah, at the end of the journey, what we have. So I think I depicted most of the points, what we have now. So we are flexible for new customers which are coming, which are going, which are growing. So we have an infrastructure that keeps care that what we want is the desired state that we want is always strived to be there. We have our scalability. We don't have any more deployment and maintenance downtime, so at least the availability is there. And we are as well more independent on the deployment, and we have a good visibility. So at the moment we can really see everything, and we have the control on everything. So yeah, some pain points. Yes, writing the CI/CD pipeline, deployment script with shell script and directly with Helm was a pain in the foot. Yes, in the feet. Also, yes, we work with Java, and Java and containers can be sometimes not best friends, and the tuning of the JVM, of the container, of the resources, and analyze the first kill, the first shoot we got from Kubernetes because the pod was just using too much memory or too much CPU. Yeah, we learned a lot on this path, but it's doable. So after you know how to tune it, it's the same pattern at the end. And also, yeah, last but not least, the YAML indentation. That sometimes it's just yeah, going into nerves. So you need the scaler. Okay, so I think it's all from my side. Yeah, and we really enjoy to work as well. So the managed part, so how it's called, we are working with Mark, and it's really nice because it's yeah, with Nick and the guys, it's really good to work together. They are really competent as well. So thank you all. So we have, if anyone has questions, so how can I see the question?
Well, thank you very much, Lorenzo. There were no questions until now. I had a question: how many pizzas we have left, Silvano? Or you want to have the last one at the end? Good. So if there are no questions, we can switch over to Helge. He was 10 seconds ago in the call and left now, so I'm not sure what happened to Helge, who has the next call. So I suggest that Silvana is giving out the pizza, and we wait for Helge. Thank you very much, Lorenzo. Okay, we are waiting for Helge. Silvana is the proof that he was just in the call just until before. So maybe Lorenzo, there was a question. Maybe you can take it easy and come over to me.
Yes, I'm in the chat.
I suggest that Silvana is doing a question, and
Who is doing the question?
as the question was from Flora.
Florent.
He asked, Argo CD is running directly inside GKE cluster.
Yes.
I think that can even, I give the answer. As far as I understood, we have as 9, the managed part, we have a separate node pool that we put all the stuff that we manage in, and Argo CD is running there. Is that correct?
Yes.
Okay. Okay, we're waiting for Helge, and have a look at the chat. Okay, should I write Helge an email, or what's happened? So Florent had another comment. You're writing to him. That's good. Yeah. Okay, I can hear from Silvana that Helge has internet problems. Helge is back. Hello, Helge. Waiting for the ninjas to show up. Okay. Helge is back on Google Meet that we used for internal communication and what is connected to my mobile phone. So here is Helge. Maybe I need to reload the ninjas. I hope they like that. Last time they didn't like reloads. Okay. Yeah. So I can see Helge now. That's great. Checking his slides. His slides are here. That's great. But I lost. Okay, say something, Helge. See if your sound.
Test, 1, 2.
Wonderful.
Test.
So, okay, so I kind of, it's good that I'm not the only one that having technical problems today. Helge looks a bit stressed, maybe like I did 2 hours or almost 1.5 hours ago. So I would like to introduce Helge, who is talking about their company and their issues on Google Cloud, Market Logic Software. So the stage is yours, Helge. Switching over.
Okay, let's see if that is working. So that looks very laggy on YouTube, but I will give it a try. So we didn't have any GCP issues, just as a pre-hint, but let's just start with the presentation, right? So I'm Helge Rennicke. I'm Director of Software Development at Market Logic and working here for about 6 years. And what we are doing at the company, so we are, let's say, I'll just give an example. So if you just go into your kitchen or into your bathroom, just open any shelf and then you will see different products there and just grab one out of it and just take a look on who was developing it or who is providing it. You will see companies also which are located here on the screen. So you will see L'Oreal, you will see Kellogg's, Coca-Cola, you will see Mars, Procter & Gamble products, for example. And the question is, how do these companies are going to innovate these kind of products? Because this can become quite expensive to know what the customers really want to have, what they, how the packaging should look like, where it should be located at storages and so on. And for, let's say, digital people like we are, it's quite easy because, say, you have innovation just out of the blue. You just put one developer on a computer and start programming. You have innovation, right? So, but for these kind of companies, innovation can become very expensive, large scale, and also very delayed. And what our company and software is doing, we are supporting them in this innovation process. But as this is a tech call here, let's talk about technical stuff, right? And I also don't want to talk about the fancy new features we are using on GCP. I want to talk about how our innovation path looked like on a technical perspective. For that, I will go back in time. And let's say 5 years back, starting with 2015, and showing you, hey, we had a very big monolith as an application, and how we were going between the years, changing different topics and stuff to become a scalable Kubernetes infrastructure landscape and multi-tenant architecture. So let's start with the super old stuff. It sounds very funny when I start talking about it because it's unbelievable that we ever had it. I will not go into details of every point here, but just to have a rough overview what environment we had. So for example, here we had 150 single bare metal nodes, which needs to be maintained and also updated and with different tenants on it, yeah. And we also had mixed Linux Windows installation, which is also a very interesting landscape and gives different issues on deploying the software. And to make it even more complex, we had also on-premise installations. And this can become super difficult if you don't have the right infrastructure and people who are doing it. From the application point of view, this was, I have to say it was, it's not is anymore, but was a three-tier architecture, right? So you have a database under the hood, a JBoss 4.2, which was quite outdated at that time already, and GWT, Google Web Toolkit, if you don't know these 3 letters, application in front of it. So sounds easy, hey, it's just 3 tiers, right? So who cares, easy. But if you just open now how big the application was. So we had 20 million lines of Java code. Yeah, we had a Snowflake database model with thousands of tables. And if you just imagine what that means on a SQL statement level, you can imagine that if you do join, union, left, right, this is an quite interesting part. So to make it more, let's say, not bad, worse, however it is, depends on if you having issues with it or not, is at that time we had no standardized build tool also. So we were just creating custom ARN script. I think just the ARN script were more than 100 or 200,000 lines. And we were doing a cron tab based build. So every 1 hour, every 10 hours, every week, we were doing the builds, right? No Nexus. No. Also the version numbering. I don't think I will ever talk again in my life about how a version number should look like for artifacts. Of course, nowadays it's major, minor, micro, and some kind of prefix. And also 6 hours downtime for a deployment, for a single deployment, is not what you would call CI/CD nowadays. And also the turnaround times for developers with about 1 hour for a single commit is far too much. And this is where we are coming from. So I think it can maybe not be more worse, but interesting to have it. Then the question was, hey, how we can get out of this, how we can split it, and how we can make the turnaround times for the developers even better. Yeah? So it was at that time even hard to hire people because no one was knowing anything about GWT. And if they were looking look into the software, they were already understanding that this is a dead end system. So at that point, we were eliminating the Windows environment and everything was on Linux. And we were starting to split off these 20 million line application into several parts. We were introducing React JavaScript as a fat var on the Tomcat level. And we were also introducing Spring Boot 1.3 into it. And this was incredibly increasing the amount of turnaround times. Drawback of the Spring Boot topic is that we don't have web services before. Then we had web services, but these Spring Boots were needing to connect to the JBoss via RMI protocol. And I don't think you will have any luck with Google to find any useful documentation how to connect Spring Boot to RMI connector of the JBoss. But in the end, it worked. We were changing also this ARN style build to a Gradle build because the Maven one was too strict. We were not able to make that in time. But the Gradle one is more like, has more scripting support. So this was a more useful way to go. We were introducing Nexus. We were introducing the first automated test in our company. And still we had a lot of manual testing also. We introduced Maven style versioning, and maybe the most important and undervalued point, we introduced Google code formatting of the Java code. I have no idea how long I was discussing with developers what is the right style of formatting the Java code, if the curly bracket should be at the end or at the beginning. Should you have intent of 2, 3, 4 with tabs, without tabs, with spaces? And the difference between the IntelliJ and Eclipse formatting is small, but the version system on commit and merges don't like that at all. So the Google formatting was helping us here. And also we were introducing a pre-commit hook, which was checking if the code formatting was even applied and refusing the commit. That was most major step in our company history, I think. And last but not least, we were also introducing a tailored template. This is some kind of layouting of how a development project for a component should look like. So that's that you are using Gradle, that you are using the directories in that structure, how the structures inside, how tests are made, how integration tests are made, that we are using APIs and so on. So this gives some kind of blueprinting style to the developer and to not have too many creativity. This can sometimes be good and sometimes be not. Let's say it like this. Okay, 2017. Right, so now we had several small pieces of Spring Boots. And then was the question, yeah, how we can make it more scalable, how we can do failovers, how we can bring that to our customers, and how we can make sure that this hundreds of Spring Boots, which we might have in future, is not overkilling the resource requests we have, right? So we still had these bare metal single nodes for each tenant. We were introducing Docker at the first place. And we also introduced the first time Kubernetes on a 1.4 installation. But if I remember back correctly, at that time you had only local disk and no remote PVCs. And you had no cron jobs inside the K8, and that's quite funny. At that time, we also introduced Grafana and Prometheus as monitoring because we noted quite fast that as more components you have, as more complex it will be to analyze any kind of application issues. Yeah, so if you have strange random system behavior, who's the root cause, how to find it. So you will need insights of the monitoring in any case of that. Yeah. So I said we introduced Docker on all cases and also migrated all of the stuff from these Tomcat-based deploy to Docker-based deploy. So we turned around the way how it is made. And at that time, nowadays it sounds super weird, but at that time we were discussing about how we can orchestrate all these kind of Dockers, right? So at that time you had just 1, 2, 3, 4, 10 Dockers maybe on your machine. And we were asking, yeah, but how you can synchronize them, how you can manage them, how you can update them even. And we were looking into different options, how we can do it. And K8 was only one part of it. I think for some time, we even had the idea to make our own orchestration framework with Ansible. And we also started to do that. But for lucky reasons, we were not continuing on it. Positive effect of all of these kind of splitting is that the microservices were supporting heavily the splitting of responsibility. So who is owning and who is responsible for doing something if you need a new feature, if you have a buggy feature and need to do something about it. Yeah. So then was right here, there's a problem in that component. That's why it's your issue. Do it. And also the messaging question was at that time very valid, and we decided for Kafka in favor of Rabbit and ActiveMQ. But this also has then some impact on the application logic. However, 1 year later, we were having everything on Kubernetes, so there was no application anymore running, or the current development at least was not running on any other environment anymore. We were also having shared nodes for the environment, and you see here Kubernetes bare metal with 50 nodes. It was already 750 CPUs, 6 terabyte of RAM. We did manual upgrades of the Kubernetes. I don't want to remember that, but we did it. So from 1.4 to 1.8, from 8 to 10 and to 12. We were using the Rook and Ceph file system, which is very interesting. So if you want to do something like this is something you should look into. We also had this change between KubeSpray and kubeadm, most difficult change we had on our end, I think. But we introduced something which is auto DNS registration for ingress. So that's quite interesting. Currently, if you are creating an ingress, it's assigning the cluster IP to the ingress, but the DNS name is not registered. So this is something we automated, and this is the reduced amount of manual work for our operation and SRE people heavily. I have to point out this part here with the IaC stack. So if you have so many different services, and the strategy before was log to local file, the strategy is not valid anymore. So you need to have some kind of distributed logging, and Elasticsearch Kibana stack was fitting that quite well. but it was overloaded. So we can, for our end, we cannot use the standard one because it's instantly overloaded with the amount of blocks going. Same goes for Grafana and Prometheus. So just imagine, at that time we had 50 gigabytes of metric data scraped per 30 seconds. So you can imagine what that means on the disk. On the architecture level, we changed now at this here fully from this 3-tier architecture to server mesh. We tried to prevent it and make it like a tree, but we failed. So now it's like a mesh. Everyone is calling everywhere, more or less, I have to say. But something which is super important we introduced was we introduced not just Spring Boot backend microservices, but we also introduced micro front ends. Yeah, so that means that you have not this fat var React packaging anymore, but you have per team, per use case, per component, you have some kind of UI you can deploy independently from the rest of the application. So that means you can deploy a full use case without interfering anyone else. What else we were using? Helm. Yeah, it's quite standard today. At that time, not. I think we were also making some bug fixes on Helm. We were also using Helm's Man in favor of Helm Umbrella because we were screwing the Helm Umbrella deployment simply because of the size of the YAML file. So the YAML file was that large that the Helm Umbrella was not able to transfer it anymore to the tiller pod on the Kubernetes cluster. And finally, we were going live with that application in a big meeting in a cinema, and everyone was super happy that this was working out finally, and it was a big party, and I like to remember that. Some learnings we took out of that year is do not overcommit on pod memory, bad idea, otherwise you will have OOM killed from the kernel level. And telepresence, this can port forward your local machine into the cluster and let's use the services there. Has some advantages and some disadvantages. If you develop, it's cool. If you do it on production, it's a bad idea. Make sure that your overlay network is monitored because at that time also we were encountering this massive increasing of nodes that limits the default limits of the Kubernetes and the default limits of the overlay network was reaching the limit. So you have to tweak it and you need to know what you're doing there. Otherwise, it will start to react very strange. And we were introducing fortified Docker containers. That means that you have read-only containers and everything else inside that Alpine or Debian or Ubuntu image is more or less deleted. And that's super important when you want to secure your environment. And last but not least, Rancher, we were introducing to limit the developers from accessing our clusters because at that time, you were only able to give people access to the Kubernetes, but not revoke it. As you had to give the certificate file out, you could use it at any time, but you could not say if you were offboarding people or wanted to limit the access for a guy, that this can be revoked. So we introduced Rancher not to deploy and maintain our clusters, just to link our Active Directory with the Kubernetes access. Yeah? And then we had the idea that with this bare metal, the number of incidents we had with the bare metal was increasing. So we had to take care of disk changes, network adapter 40, and also just buying new hardware was taking a week. So it could not react instantly on the issues we had. And we were having at that time the idea, hey, we can go to a cloud provider, right? So we were switching not to Google, but to a cloud provider. And I think that's why we had a year of disasters. On this cloud provider, I think we encountered more or less everything what's possible. So main issue here was that the nodes got time desynced. Yeah, so that means that node 1 is more than 5 minutes out of range of another node. So we had to introduce our own time synchronization. We had to suffer PVC remounting issues. So that means if your Kafka 5-node, if you have a 5-node Kafka or Zookeeper or Postgres, Elastic, whatever it is, with a stateful disk, then you are killing a node, or you want to drain a node, or you want to shift that pod to another node. The disk needs to be remounted to that new node, right? So, and this was not working. So a remounting of a single disk was taking up to 30 minutes, 30 minutes. Now, so for a 5-instance Kafka, you were needing 30 minutes multiplied by 5 because it was also serialized. And even to make it even more worse, we were hitting the cloud provider hard-coded quota limit inside the Kube API. So that means that the pod scheduler, for example, could not schedule any more pods. So the daemon sets were failing. You could not deploy a normal daemon set anymore because he could not deploy, he could not react to that change. And in the end, we were writing a synthetic test so you could spawn a vanilla Kubernetes cluster, just deploy that synthetic test to it, and was instantly crashing in that way that not even the expert support from that cloud provider could save that cluster from the fail state. In the end, we were hiring external consultants. We were also discussing with the developers directly who was from that cloud provider developing that feature for this guy. And I think if you take a look on the 1.14 and 1.15 changelogs of Kubernetes, all of the issues you find there regarding PVCs or disks are our issues. Okay, but anyway, 2020, in the end of 2019, I convinced then our C-level to make a change from this cloud provider to another one. So we were switching all of our environments within about 3 days to Google Kubernetes. So I was just going to the CTO and saying, hey, I need a credit card. And he was saying, hey, why you need my credit card? And he was already scared, and that was right that he was scared. So we were just buying as many nodes as we could, and I think that was stretching the approval process even within Google up to the limits. But in the end, we had about 100 nodes, 1,500 CPUs, 12 terabyte of RAM. That was one cluster out of 5. We were migrating. And so we have about 600 pods running in environment. We have Kubernetes 16 and 17 now running. And we are using Velero for snapshotting the backups. We now finally have Let's Encrypt, auto certification creation, auto DNS registration, and also status cake. That's, you have external tests running. And we are experimenting right now with WAF and CloudNut. We still have the Grafana Prometheus stack. And right now, more than 100 Spring Boot microservices in one environment, and also more than 50 micro front ends. And oh, there's one slide missing. Let's see if I can scroll down here. Yeah. So most boring part is there was no disaster. So everyone was just waiting. Hey, when the next bad thing will happen? And nothing happened. So what we had to do in this year was we had to do a DRP, disaster recovery training, to fulfill our requirements from the auditors, because there was no disaster in that year. So we had to do it on our own. Learnings from that year is you should not use Rapid Channel in Google Kubernetes. Then some other presenter here was already saying, hey, fun with preemptive nodes. I can totally agree with him. If you're going for preemptive nodes, you should be aware of that there is lots of pod terminations because the nodes are fading away often. And there seems to be a state missing in between running and terminating, whereas the SVC HTTP routing is still going to that pod. You need to be aware of that you use post the pre-stop here carefully. If you have something like Java Spring Boot running, you should be aware that it needs to support shutdown, graceful shutdown fully. And also affinity and anti-affinity is your friend. It sounds easy, but it's easy to forget. And containerd versus dockerd is a quite cool performance improvement without any impact. So we are running all of our clusters in containerd, and that's working super nice. So 2021, the question is what to do now, right? So as everything is working, we need to find something new to work on. What we are currently looking into is, of course, more innovation. And we are interested in these serverless services. Or different topic would be GKE scale down to zero. That would be possible with custom metrics on the HPA. Then we are doing a Google Vision integration right now. Then also upcoming data plane changes might be interesting for
Looks like Helge has again internet problems. Was right at the interesting spot. I hope it takes not so long like before for him to come back. Oh, Helge, are you back? Oh, okay. I see. I currently have you not on the Ninja, so I reload that. Maybe your internet connection had a hiccup. Let's check. I pressed reload. Let's wait for it to come back. Then we can. Oh, now it's coming again. So okay, I give you back the slides. Okay.
So yes, no, maybe. Good. So 21, right? So serverless services, GKE scale down to zero would be an option. Upcoming data plane changes would be potentially interesting, and training sounds easy, but it's not, as we are advancing quite fast in the technology. Also, we have to care now for that our people are even getting behind or on board or up to date. It's quite hard right now to make that happen. And also something very interesting, what was just released is native snapshot on now available, and I really like it. And last but not least, before I come to the question part, I would have to say code formatting enforcement for the win. Yeah, don't miss to check out Rancher. Then I have a question to the community: why there is a node pod limit of 110? No one could answer that question to me in the last years. I would propose taking a look on KubeCost for the component cost transparency and have fun with tracing. And now I'm open for any questions coming up.
Okay, thank you very much, Helge. We're waiting for the delay here. I'm writing. Are there any questions? Maybe people are already tired and hungry for the ones that did not get pizza.
I would like to have also pizza.
It's Switzerland only, sorry. Maybe I can get one. Okay, Helge had a question to you guys. Maybe Silvana can answer that question in the chat. Why is this limit of 110? What was it?
110 pods per node. Why we have this limit? I could not find any Kubernetes expert who could give a useful answer to that question.
Okay, I think there must be someone from Google, or should answer someone from Google. Maybe they don't know. Or the guys that know it, they don't talk to the customers. I'm not sure.
Anyway, I'm using this chance here.
Okay, so no reaction from the audience until now. We have still 23 people in the chat, or in the stream. Florent says thank you. So if there aren't any more questions or comments, I really like the talk. never heard a talk of hitting so many limits and so many switches of providers. I'm sorry for the wrong introduction. Seems like Google is the best choice for you.
At least it was saving my life in the last year. And as I now don't need to react on disasters anymore, I can go through the innovation path.
Cool. Okay. Yeah, so I would like to thank you very much to Helge, and thanks for waiting, everyone, and thanks for inconvenience. So I say bye to Helge. It was nice to have you here. Thank you.
Thank you very much. It was nice to be here, and hope to see you soon.
Thanks. Okay, so thank you very much, and sorry again for the delays, and see how I can debug that, or just use a different computer, a stronger computer that this doesn't happen again. It was quite annoying if you can't even move the mouse around, or if the keyboard entries have a delay. So if I cannot ask you if you liked the talk, I would like to ask if you liked our debugging, and if you do so, please give us a thumbs up, and I would be very happy to see you next time. Thank you very much, and have a nice evening. Bye.